I'm Paris, and I'm going to talk about some of the basic underlying technology that kind of enables augmented reality apps to function. And I'm going to talk about 3 ways that we kind of pin some of these virtual objects to the physical world. And then maybe you can look at some virtual reality app in the future, or some augmented reality app, excuse me, and kind of understand how it's working. So jumping right in. So there's kind of this umbrella term of extended reality. And on one hand, you have virtual reality. In virtual reality, you're kind of completely submersed in the virtual world, and you have virtual objects and a virtual environment. But on the other hand, in augmented reality, you'll have these virtual objects, but you'll also have them kind of intertwined with some physical objects. And you have the real world environment here. So you might have like a camera where you're seeing the actual physical location, but you have some pixels on top of that are making an object. Or you might have like a transparent display that you're seeing through, but you're sort of seeing the virtual objects as well. So probably more people have heard of virtual reality, and not as many people have heard of augmented reality. And why is that? There are these big companies that are making these virtual reality headsets like Oculus and HTC with the Vive, and those are kind of already caught on. And why is augmented reality not doing that? The main reason, probably the first big reason, is computer vision. So augmented reality is basically at its core a computer vision problem, because in virtual reality you have these virtual worlds, and so if you're off by a little bit where you're placing it, it's a virtual world that nobody really understands anyway, and you have a lot more control in there, and you can place everything where you want it. In augmented reality, you need everything to line up really well, and as soon as you have like a little tooltip that's supposed to go over some object and it's just off by, I don't know, half a meter, then that's pretty big, and you start to realize it pretty quickly, and your immersion is ruined. One of the other reasons is a lot of people don't really know how to do it yet. It's pretty new, and a lot of these use cases are just honestly pretty gimmicky. So you'll have something like Pokemon Go, where everyone was really excited to see their Pokemon that they were catching. They'd use it for maybe 2-3 times. And then every time after that, they would disable that feature because it was kind of getting in the way and slowing down everything. And you're kind of supposed to enhance the experience and not detract from it in any way. Another thing that's kind of getting in the way is the device affordability. So there's augmented reality for smartphones, and generally, I guess smartphones are pretty accessible now. But you have more complex experiences that are in devices like the Microsoft HoloLens and the Magic Leap devices. And some of those are multi-$1,000 devices, so nobody's going to use those. So a lot of people are kind of stuck to using the smartphone applications. And lastly, a lot of people don't really want to just kind of wave their phone around and just make a big scene when they're in public. Additionally, if you have something like Google Glass, kind of draws a lot of attention to you, and people don't really like to do that. So how do we actually position these objects? This is kind of the base problem here, and so we use some computer vision techniques to place these objects, and one of the trackable objects that we will use is an image target. They'll also use face meshes, and they'll make anchors from these feature points that the device has collected. So I'm going to talk about all 3 of these, and I'll kind of give examples of what they might look like. So to start it off, we have image targets. So in this app here, I've sort of put in this ace of spades as the image for it to track. And once it sees the image, it'll go ahead and throw this cool little hologram in here. And right here, you'll see it probably clip away. So it lost vision of it there. So some of it, if it doesn't quite see that exact image, it won't throw up the virtual image that you're looking to put there. but it doesn't really care too much about the environment. It's only really looking for this one image. The next one is face meshes. So this will generally plot all of these points on your face, common points that most people will have on their face. And so then you can kind of stretch whatever virtual objects. This is used in like Snapchat filters and stuff like that to put like animal faces on people. But it's also used in some industries to kind of preview products before you're going to buy them, like glasses or makeup. And lastly, we have anchors from feature points, and this one's a little bit more complex, so I'm going to take a little bit longer on it. So this one, the feature points are these yellow dots in this image. So this one is caring a lot more about its environment that it's in. So it's going to start looking for all of these feature points because it doesn't have anything specific it's looking for yet. And this little circle right here is actually the anchor itself. So how does the device actually go through and kind of realize what's going on here? Basically, when it starts, there's nothing. And it basically has no idea where it is. And it could have some little hints from something like GPS or Bluetooth beacons, but it doesn't really rely on that too well because it's not extremely accurate. So what does it do next? It starts looking for feature points. And so here we kind of have the same-ish image from two perspectives. You'll see the angles are a little bit off here. And so it's looking for these visually distinct features within this image. So you'll see sort of on these big panels of white wood, there's not going to be anything there because it can't really detect anything interesting. So it's going to be along a lot of these corners and edges. And so in this top right, we're going to have a little indicator to see how close we are to dropping anchors. So moving on to the next step, the device is going to do some localization and mapping. So now that it has a couple feature points, once it starts to move around, it can start to realize where it is inside the space. So that's the localization. So it'll like triangulate its position with some depth algorithms. And then on the other side, while it's still doing the localization, it'll start to construct the map of where all these feature points are. So pretty much its understanding of the space is only the feature points. So it's going to be like this cloud of all of these dots, and that's all it really knows. Once it has a bunch of the feature points, it's going to go ahead and it'll start to estimate planes, because this is, I guess, kind of how it will start to give it an understanding of the rooms. And that'll sort of link it to more how we understand physical spaces. So you'll see here in the picture on the left, we have a couple feature points, and it's sort of made this yellow plane over this whole section. And it's not quite stretching across the bed. So when we progress and we get a couple more feature points, it'll start to kind of reevaluate the plane, and it'll realize it needs to expand that. And then once it has all of that, we can finally place an anchor. So there are a couple ways that you can kind of input anchors. A lot of it's not super well defined yet, but in this example, I'm just kind of touching on the screen, and I'm dropping this anchor, and I'm going to name it the floor, a couple typos in there, and then it'll go ahead and place the anchor. And so when you place the anchor, it's kind of taking the cluster of feature points that are around it, so the visual distinct features, and it'll kind of use that as a signature for how it's going to recognize this anchor in the future. And basically, you can start to upload that to the cloud, or you can share it directly with some other people or save it on the device. And next time you come to this location, it'll start to see some of the feature points. And maybe at the beginning, it won't quite realize where it is if it just has a couple of them. But once it gets enough and it passes a threshold, it'll start to realize where it is again, and it can drop your anchor for you, and you can start to see the whatever virtual object you place. And that's pretty much the three there. So hopefully you have a little bit of an understanding of how some of it works, and yeah, hopefully you can start to think of some better use cases than we have maybe out there in the wild right now, because it's a pretty new field, and I think it just needs people to figure out what's going on. Yeah, thank you.